Okay, in this video we are going to put everything together when we graph sine and cosine. We're going to see amplitudes along with period changes and phase and vertical shifts. So what does the equation look like when you have all of these together? Well, we get y equals c plus a sine of b times the quantity x minus d. And you notice that we factor this b out of x so that we can calculate the correct phase shift. So if your b is not factored out, you need to factor that out before you get started. So also the same type of equation for a cosine function, y equals c plus a cosine of b times x minus d. Again, capital A is going to be your amplitude, and it's the absolute value of little a. Our period tau is 2 pi over b. Our phase shift is d, and our vertical shift is c. So a key point here is if you have a phase shift, if that's present in your equation, you must calculate the beginning and the end of one period so that you know where to start and end. If there is no phase shift, the beginning and end are at 0. The beginning will be at 0 without any phase shift, and the end of the period will be 2 pi over b, which is just your period calculation. So let's get started here, and I want you to notice our b value is not factored out, so we need to go ahead and factor that out before we get started. So when we factor that 1/2 out, it will be x plus pi. And remember, when you factor out, if we want to factor out a fraction from pi over 2, we divide it by that fraction, and I can multiply to get rid of this complex fraction, so I get pi over 1, or just pi, and that's what you see right up here. So I have, for convenience sake, I have already calculated all of the things that I need. I have an amplitude of a quarter. I have a period. When I divide 2 pi by 1/2, I get 4 pi. A phase shift. Remember, my phase, I have to have x minus. So an equivalent expression is x minus negative pi. So my phase shift is negative pi to the left by pi. And then my vertical shift is 0. We will not be moving this graph up or down. So because I have a phase shift, I need to calculate the beginning of my first period. So let's go ahead and calculate that. I set everything that's in these parentheses to 0. So I have 1/2 x plus pi over 2 equals 0. And then I'm going to multiply everything by 2 to get x plus pi equals 0, or x equals negative pi. So that's going to be the beginning of a period, and the end of my period is going to be 1/2 x plus pi over 2 equals 2 pi. And when I multiply everything by 2, I get x plus pi equals 4 pi, or x equals 3 pi. So I need to mark those off on my my graph paper. So I know that the distance between negative pi and 3 pi, there's 4. So that is very convenient. So I go negative pi to positive 3 pi. I don't know why I put that underline there, 3 pi. And now I'm going to mark the midpoint, which is going to be at pi, the quarter mark, which is at 0, and then the 3/4 mark, which will be at 2 pi. And because we want to graph this over 2 periods, I'm going to go backwards these 4. I'm going to go 1, 2, 3, 4, and that will be another period. So this is going to be negative 1, 2, 3, 4, 5, negative 5 pi. This will be a negative 3 pi, a negative 4 pi, and a negative 2 pi. So now I can get started graphing. So I know I need to plug in negative pi, 0, pi, 2 pi into my equation. But I do want you to remember that when I plug in all of these points, I end up getting just the original quadrantal angles for those points. So I will get cosine of 0. I will get cosine of pi over 2. I will get cosine of pi, and then I will get cosine of 3 pi over 2, and then I will get, I will go back to the original since 2 pi, and since 0 and 2 pi are the same, it'll just give me the same answer for negative pi. All right, so I know the cosine of 0 is 1, so I will be at negative a quarter when I'm at negative pi. At 0, I know the cosine of pi over 2 is 0, so I will be at 0. At pi, the cosine of pi will be negative 1, so I'll be above the x-axis. And then at 3 pi over 2, I know that's 0, so I'll be right on the x-axis. And then when I plug in 3 pi, that will be negative 1/4 cosine of 2 pi, which is 1. So I'll be below the x-axis by a quarter. So this is a really kind of a flat curve. And I'll go ahead and reproduce that period over here. Okay, so that is the graph of negative 1/4 cosine of a half x plus pi over 2. So now let's go down and do something just slightly more complicated. Here I have tick marks already ticked off so that I don't have to do that in our calculations, but I do need to definitely factor out that 3/4. So I get 1 minus a quarter sine of 3/4 times x plus, okay, so if I factor out that 3/4, I'm dividing by 3/4, and I think I'll multiply by 8 over 8 to get rid of this ugly fraction, complex fraction. So I get pi over 6. And remember, I really should write this as a subtraction so I can see what that phase shift will be. It'll be a negative pi over 6. So for convenience sake, I went and I calculated all of these values here. My amplitude is the absolute value of negative 1/4 because A is negative 1/4. It's the number in front of sine. My B value is 3/4, so I plug that into my calculation for my period, and I got 8 pi over 3. My phase shift is negative pi over 6, and my vertical shift is 1. So again, I'm going to mark off my vertical shift, and I'm going to use 2 to mark off my vertical shift because I know my amplitude is a quarter, which means this graph is going to be really flat again. And I kind of want to see what it looks like. All right, so let's go ahead. We do have a phase shift. We will find the beginning. So we will take the 3/4 x plus pi over 8 and we'll set it equal to 0. We'll multiply by 8 to get rid of our fractions. When we subtract pi and divide by 6, we get a starting point of negative pi over 6. And then our end, when we calculate that, 3/4 x plus pi over 8 equals 2 pi. We're going to multiply everything by 8. So we get 6x plus pi equals 16 pi. 6x equals 15 pi. And then when we divide, I get 15 pi over 6. And those are pretty small increments. I need 16 pi over 6's in between these two. So I divided each one of my big regions on my x-axis into 4 smaller parts. And I'm going to go ahead and find negative pi over 6, and that'll be this one, negative pi over 6. And now I'm going to go ahead and find 15 pi over 6. So that's 4, 8, 12, and this one will be 15. All right, so halfway in between, since there's 16 separating, that'll be 8. So this is going to be 7 pi over 6. And then if I find the quarter and 3/4 marks, this is going to be 3 pi over 6 or pi over 2. And this is going to be 11 pi over 6. If I go backwards 16 tick marks, I'm not sure I even have marked enough. That's 4, 8, 12, 16. Okay, I did mark enough. So if I go backwards 16, I'm at negative 17 pi over 6. I know that 8 is half of those 16, so this is going to be a negative 9 pi over 6, which simplifies to negative 3 pi over 2. If I go back and find a quarter of those, a quarter of 16 is 4 tick marks, so I'm at negative 5 pi over 6. And then I'm at, let's see, that was a 9 and 4. That's going to be a negative 13 pi over 6. So now I'm ready to go ahead and calculate my values. I know when I plug in my begin and end points, when I do negative pi over 6, I'm just going to get 1 minus a quarter of the sine of 0. When I plug in pi over 2, I'm going to get 1 minus a quarter of the sine of pi over 2. When I plug in 7 pi over 6, I'm going to get 1 minus a quarter of the sine of pi. When I plug in 11 pi over 6, I'll get 1 minus a quarter of the sine of 3 pi over 2, and when I plug in 15 pi over 6, I'll get 1 minus a quarter sine of 2 pi. So I know the sine of 0 is 0, so in this case I'll just get a 1 at pi over 6. At pi over 2, I know the sine of pi over 2 is 1, so I'll get 3/4 at pi over 2. Oh, 3/4, I'm sorry, 3/4. Yes, and then at 7 pi over 6, I will get the sine of pi is 0, so I'll get 1 again. At 11 pi over 6, the sine of 3 pi over 2 is negative 1, so I'll get 5 pi or 5/4. And then at 15 pi, I will have the sine of 2 pi, which is 0, so I'm back at 1 again. And so when I graph it, it looks like this. So I'll just duplicate those points. And I'll graph it again. And that is my graph.